All right, so we're doing 4c. 2p squared equals 4p minus 2m plus 6, and then we have that other equation. That's the one you're talking about? Okay. I don't know. Does it tell us what we're supposed to do? It says you're supposed to use elimination. Okay. Now, one of the difficulties here is that everything is all over the place. Like, the top equation has my p squareds on the left and my p's on the right, and the bottom equation has all my p's on the right. We have to make a decision. So I would probably, it doesn't really matter, but I would probably take the first equation and at least put the p's together on one side. Okay? And then that leaves me with my numbers and my m's on the other side. And that's okay. We can go with that. You don't have to put it all equal to 0. I know your textbook likes to move everything over to one side except for the number. It doesn't matter. What matters is I want to write this equation in this format. And the first thing I'm going to do is just read it backwards. Okay, so I know that this stuff is on the right, but if I read it backwards, it's on the left. And even just by writing that, I can see that now I can line things up. And I will be honest with you. Well, first of all, we have to get rid of the m's. You cannot get rid of the quadratic terms by elimination or substitution. I'll be honest with you, this is a tough problem no matter which method you use. If you use elimination, it's a lot of work. If you use substitution, it's probably worse. But the only way for me to get rid of those m's is to multiply the top equation by 5 and the bottom equation by 2. And that will give me negative 10m in the top equation and positive 10m in the bottom equation. And I would like to have enough room where I could just do that left to right, but there's too much. So equation 1 becomes 10p squared minus 20p is equal to negative 10m plus 30. And I will double check all my multiplications in a second. My bottom equation becomes 10p squared plus, I see what the problem is going to be here. Wow, that's a drag. So we'll double, it's not a drag. It makes it actually easy. I'll tell you what's going on in a second. I get 10p squared minus 20p equals negative 10m plus 30. I get 10p squared plus 20p equals 10m plus 12. Good. So what happens if we add the equations to get rid of the m's? Well, an unintended consequence of that is we happen to get rid of, oh no, we don't get rid of the p's, do we? We're still left with p squareds. Unless one was supposed to be negative. Nope. So we end up with 20p squared equals 42. I want to double check everything here because this doesn't seem right to me. So I moved that p over, negative 2m plus 6 is fine. I read that backwards and that's okay. Oh, do you see my mistake? What is it, Leighton? Right, this should be an 8, which means this is 16. Not, not that it really makes things much simpler. I'm still going to get a wacky number. I get 46 here, but I do want to continue and double check everything. Times 2 is 10, 20, 10, 16. Times 5 is 30, negative 10, negative 20, and 10. So that looks okay. That means that p squared is equal to 46 over 20, which is 23 over 10. Oh, yuck. Yuck. Is that the, are they saying in the back that P is some weird decimal of like approximately 1.4 something or 1.5 something? They are. So, and those of you that have found it already, I just want to make sure. This is the number they have in the back. Okay. So I guess it is what it is. We have two solutions. One has a p-value of the square root of 2.3. 2.3, Shannon, is just the 23 divided by 10. And the other solution has a p-value of negative root 2.3. Oh man, to find m, this is a real drag. To find m, we have to put that number into one of these equations. I would probably, doesn't really matter, I would probably just move that 8 over in the bottom equation. So then I could take that square root of 2.3, square it, multiply by 5, plus 10 times it, and then minus 8, and then divide by 5. So if I go with this one, I'm going to have 5 times that squared plus 10 times that minus 8, about 18.6. If you do the other one, you get negative 11.66. Just trying to decide how important it is that you would be able to do questions that devolve into this mess where you have, you know, the square root of 23 over 10, and I would say it's not that important. I mean, it's good practice, but it's not that big of a deal. Other questions? Yeah, Sasha. 4B? All right. 4B is primed for elimination. And the reason is the x squareds are lined up with x squareds, y's and y's line up, x's and x's line up, and numbers line up. As well, one of the equations has negative y and one has positive y. So I don't even need to really do any prep work here to eliminate a variable. I just add the equations and get 2x squared equals 15x plus 8. Do you see how I got to that point? Okay. It's quadratic, so I need to zero the equation. 2x squared minus 15x minus 8 equals 0. I would rather factor. I know sometimes I say I don't like factoring, but I would rather factor than use the quadratic formula. So let me find out if it is factorable. You can do the same thing. I think b squared minus 4ac is 289. I think 289 is 17 squared, but I would like some confirmation. Seeing some people nod. Some more people nodding. So b squared minus 4ac is 289. It's a perfect square of 17, which means it's factorable. We've had this situation before. It must be 2x and x. It has to be, right? There's no other way you can factor that 2x squared into two factors, as long as there's an x in each, which there has to be. The 8, you've been taught, trained by me almost, to always try numbers that are closer together, like 4 and 2. But 4 and 2 will be a waste of time, because if I have 4 and 2, I'm going to be forced to put an even number here. And then I would have a common factor of 2. When I look up here, this is my eyeball, there is no common factor of 2. That means it must be 1 and 8, strangely enough. And that means that the 8 has to go here, because I can't put the 8 with the 2, otherwise there'd be a common factor. So apparently this is going to work, and it does. That means 2x plus 1 is equal to 0, or x equals negative 1/2. And over here, I would say that I would expect there's nobody in the room that has to write x minus 8 equals 0. But if you do it and then solve it. We still have to find the y values, right? And that means you're going to go back up to one of the original equations. It doesn't matter which one. I'm going to go with this one. Y is equal to negative x squared plus 8x plus 19. And we can go ahead now and put in 8 and see what we get for y. Put in negative 1/2, being careful with that negative. And by the way, it's been a while since we've seen this, but I want to make sure that negative x squared means negative 1 multiplied by x squared. So you're going to put negative 1/2 in and square it. It will become positive 1/4, but then we multiply by the negative 1. Is that okay? Okay. Other questions? Go ahead. Okay, let's look at 5b. All right. It says just solve it. It doesn't tell you which method you need to use. So first of all, from a strategic standpoint, there's x squareds in each. I don't want to say it's never possible, but you don't want to try to get rid of the quadratics. It's almost never possible, which means we have to get rid of the y's. If I get rid of the y's, it's going to involve multiplying one equation by 3 and one equation by 5. So it's going to be a lot of work. Can I use substitution instead? And the answer is yes. I can rearrange the bottom equation for, well, I can't really. I was going to say I rearrange the bottom equation for x, but I can't. You can't rearrange a quadratic for the quadratic variable. So if I use substitution, I have to rearrange this equation for y or this equation for y, which is an invitation for disaster, because I'm going to have 8/5 and 1/3 and 5/3 and weird things. So I guess elimination is the way to go. The numbers right now, McKenna, are both on the right-hand side. So the only thing that is required to line things up is to nudge some of the terms around a bit on the left. I have 8x squared. And then I have plus 5y. Don't know why I changed color. I'm not sure if you see why I left a kind of a blank there. It's because my next equation has the 6x squared and it has minus x. So, by the way, you could put 0x there if you like. And minus, I thought I wrote x, minus x, and then minus 3y. So I have to use elimination. I don't have to, but man, the alternative is upsetting. Just checking to see that I've written it down correctly, and I have. So I'm going to multiply this equation by, see if we can get all of the colors in here, by 3, and this equation by 5. Do you see what that's going to accomplish? Okay. And I'll stop messing with the colors now. The top equation is 24x squared plus no x. There's no need at this point in time. Oh no, I guess I should still space things out because I've yet to add them. You don't need to write plus 0x. Plus 15y equals 300. The bottom equation will be 30x squared minus 5x. 3 times 5 is 15 minus 15y. Oh, of course, right? That's what we want. Equals 5 times 5 is 25. We're getting there. Oh, I don't like the numbers that I'm going to have, though. I'm going to have 54x squared minus 5y equals 325. Ugh. So I want to, again, your textbook goes over the line, I think, in places. I want to just look at this because this is not a pleasant equation at this point in time, but we'll give it a crack in a second. Multiply by 3, I get 24x squared plus 15y. 3 times 100 is 300. I multiply by 5, I get 30x squared minus 5x minus 15y. Well, it looks okay. Except I don't know why I wrote y there. I think it's fine. I mean, I don't have to like it, but I think it's okay. So what do I get? 54x squared minus 5x minus 325. I almost hope that it's not factorable, because then I'm just forced to use the quadratic formula. I don't want to try to factor this anyway. And if you think I'm going to try that one in my head, you got another thing coming. 25 minus 4 times 54 times negative 325. How long would you let me do that before you told me my calculator wasn't on? Quite a while, I'm guessing. Let's try that again. Negative 5 squared. Let me go back to the problem here. Okay. Negative 5 squared is 25 minus 4 times 54 times negative 325. And that looks like it might be a perfect square. It is. So it's factorable. So factor it and you're done. I'm just kidding. I really don't want to factor that. I mean, I'm guessing it's going to be 9x and 6x. I'll give it a shot. It's very late in the day for me, math-wise. 325 is 12 is 13 times 25. We'll try the 25 here and the 13 here. I don't think so. Is that right? 150 and no. I'm going to use the quadratic formula. How many of you were in the same boat as me that you look at that and you start factoring it and you go, is there anybody in the room that it's obvious how to factor that? Okay, so that makes me feel good because it's not obvious to me. I just would get more and more frustrated. Okay, so what is x equal to? X equals negative b. I'm looking from here. So 5 plus or minus the square root of b squared minus 4ac is 265. All over 2a, which is 108. Holy smokes. X equals 5 plus 265 over 108. x equals 5 minus 265 all over 108. This is 270 over 108. Which is 90 over 36, which is 10 over 4, which is 5 over 2. 5 over 2, 5 over 2, 5 over 2. Oh, man, really? That's what it factors into. So anyway, one way or another, by hook or by crook, you get 5 halves, and you also get negative 13/27. You can just check for me, please. 5 minus 265 all over 108. Is that the same as negative 13 over 27? I'm not seeing anybody say yes. Oh, it's not 13. 65. I thought 5 times 13 was 325. It's 65. So that 5 minus 265 all over 108 should be equal to negative 65 over 27. All joking aside, I'm not going to put those back in and find why, but that's what you would have to do. Yeah. Other questions? All right, so we are going to now move on to something that's really different. And we're going to be looking at linear inequalities in 2 variables. So, what is an inequality? I'm going to show you an example of an inequality. An inequality is any mathematical statement which has an inequality symbol. And that inequality symbol could be less than or equal to, it could be less than, it could be greater than or equal to, or it could be greater than. A linear inequality is going to be an inequality in which the variable is raised to the 1. That's what linear expressions are. Okay? If it's a linear inequality in one variable, then it's something like 3x plus 2 is less than or equal to 5. That's a linear inequality in one variable. And to solve that, you rearrange that inequality. We've done these. You learn about these in grade 9, maybe even grade 8. We can subtract 2 from both sides and get 3x is less than or equal to 3. And you divide both sides by 3. And you end up with x is less than or equal to 1. Am I with you on this? Are you guys with me on this? What does that mean? It means that that inequality, which is just peeking out of the top of your screen, is true for any value of x described by that line graph. You're still with me? Okay. So what we're doing today is really different because we are doing the following. What if I said to you, 3x plus 2 is less than or equal to 5 plus y? Now what we have is a linear inequality. The variables are all raised to the 1. So this is still linear. But it's in 2 variables. So that's the difference. You already know how to solve linear inequalities if there's one variable, but if there's two variables, you don't know what's going on yet. Okay. What I will tell you is that the solution to this linear inequality in two variables is complicated and it cannot be summarized by a line graph. Okay? All right, so we're going to start off with a warm-up. There is a linear inequality with two variables. The inequality is 2x minus y is greater than 1. Circle the ordered pairs that make the inequality true. So for example, and you're going to have to do a lot of scrap work either on paper or on your calculator or in your head. For example, if I look at this right here, and I have 2x minus y is greater than 1, and I put in my x value of 2 minus my y value of 3, I end up with 4 minus 3 is greater than 1. I end up with 1 is greater than 1. Is 2 comma 3 a point that makes that true? No, because 1 is not bigger than 1. If this inequality at the top of the page was this, then we would be circling that point and saying that point represents a solution. But it's not, so we don't. I'm going to give everybody 3 or 4 minutes here, and I want you to determine which, if any, of those points make the inequality true. Put your hand up and down if you've got them all. And just for my own confidence, those of you that are finished, you're in agreement. Good. Basically, the way I did it was I said, since we're doubling x and subtracting y, I want to look at the difference between those two things. So, you know, when I double 4, I get 8. 8 minus 4 is bigger than 1. And I guess I'm using the formula, but I'm just not writing it down. So we're in agreement on those. Okay. Second part of the warm-up. How many different ordered pairs are there that would make that inequality true? Let me write down the inequality here as we ponder that question. And I'm going to pick a value of y. I'm going to pick a value of y of 100. Is there any value of x that would go with that y that would make that inequality true? Well, sure. It just has to be a number that when I double is more than 101, right? Like, I mean, if I picked 1,000 here, I think it's quite clear that when you double 1,000 and then take away 100, you're still going to be greater than, it is 1, right? Is that what you have? Okay. So, Jack, what is the answer to this question? There's an infinite number of numbers. So an infinite number of solutions. By the way, if I go back to where we started with my discussion of a linear inequality with one variable, this inequality on the left-hand side of your screen has an infinite number of solutions as well. And that's what this arrow is telling us. any number on this number line to the left of 1 or at 1 is a solution. There's an infinite number. And we can draw it graphically, but it's a one-dimensional graph. All right. Plot the line 2x minus y equals 1. So let's stop for a second. I am taking the inequality and I'm imagining that it's an equality. So we are going to be graphing the line y equals 2x minus 1. And I forgot, I need to hand out rulers because I want you to do accurate work here today with this. Thank you. There you go. So we want to plot the line 2x minus y equals 1. But we're going to draw the line, thank you. We're going to draw the line using dashes and not a solid line. And many of you will pick up on why that's going to be the case sooner than others. First of all, if you want to plot a linear equation, you need to rearrange it for y. And rearranging this equation for y is really quite simple. You add y to both sides to get a positive y on the right, and you take 1 away from both sides. And what this means, I'm going to write that now as y equals 2x minus 1, is that the slope is 2 and the y-intercept is negative 1. And a slope of 2 as a fraction is 2 over 1, which means the rise is 2, the run is 1, which means you go 1 to the right and 2 up, 1 to the right and 2 up. So the y-intercept is negative 1. You go 1 to the right and 2 up, 1 to the right and 2 up. Those are just guidelines. I'm not really sure I want you to put points on the line. Okay, and that, again, will become clear in a bit. Those are just points that are guiding me to what I want to draw. So I want to put my ruler down. And sketch it. I think we're okay with that. Yes? Now what we are asked to do as well is for ordered pairs that make the inequality true, we're going to plot those points, but we're going to use a solid dot. And for ordered pairs that do not make the inequality true, we're going to use an empty dot. So I am going to freeze on my right-hand screen all of this information. This is just for me. You have it right in front of you on your handout, but I need to be able to see it as I show you what's happening here. So the point 2, 3 is not a solution, and I'm saying we're going to plot it with this. 2, 3, that's right there. So you can put a little open dot there. 4, 4 is a solution. So I'm going to use a solid dot. Now I'm drawing a big blobby dot. You don't have to draw it that big. 1, 8 is not. 5, is that 5, 10? 5, 10 is not. 3, 6 is not. 5, 9 is not. 1, negative 1 is. Negative 2, negative 6 is. Negative 4, negative 7. No can do. negative 5, 5. Negative 4, negative 10 is negative 2 comma 3. Nope. Didn't we have negative 2 comma 3? Oh, negative 2 comma 3. There we go. Negative 3 comma negative 9 is, and finally, negative 1, negative 3 is not. How many of you have an inkling as to what is going on here, what I'm driving at? Okay. So we've done C, we've plotted it. Let's take a look at D. What do you notice about the ordered pairs that are a solution to the inequality? What is true of every ordered pair that's a solution to this inequality? Yep. I would rather we not use right and left here. You are correct. When you look at the left and the right, they're all on the right. But I want us to focus on something different. Sasha? They're all below. Same thing, but whether it's left or right is not going to be important. It's going to be whether it's above or below. So what we notice is the solutions all lie below the line. And I want to point out to you that below the line means exactly that. Below the line, not on the line. In fact, I've chosen some strategic points here that happen to fall on the line, and they're not part of the solution. This is why we draw a dashed line. That line is not part of the solution. So let me write down the inequality here. 2x minus y is less than 1. Can you tell me what that inequality you think would be if we drew a solid line? Miles? Or equal to. That's right. If it was a solid line, did you notice that there were at least 3 points here that when you put x and y in, you got 1? You didn't get smaller than 1, you got 1? Imagine that it said this. Then those points would make it true, and they would be solid points on the line, and we would draw the line as a solid line. But alas, they're not, which is why we have a dotted line. Sasha? Oh, my mistake. I wrote it down wrong here. It is bigger. It is bigger. Thank you. Okay. How can all of the solutions be shown? Well, again, with a linear inequality, we just drew an arrow indicating every number that way. But here, let me ask you a question. Do you believe that this would be a solution? Let's try it just to convince ourselves. That's 5 comma 1. So put 5 in for x, 1 in for y, see if it's true. 5 times 2 is 10, minus 1 is 9. 9 is greater than 1, and it's true. So, in fact, and by the way, you could do the same thing over here. Any of these points would not make it true. So, in fact, like any point below the line. So how do we communicate that? The answer is we shade it in. It's not just an arrow pointing in one direction. We shade in the whole thing. And typically speaking, how that's shaded is entirely up to you, but you know, it might be shaded I'll just use a different color so you can see it. It might be shaded like this. So it isn't that it's a domain of x's or a range of values of y. It's a solution space. It's a two-dimensional region of space where every point in that region in space is a solution. Okay. So how can all of the solutions be shown on the graph? By shading. And show it on the grid. We've done so. Why were we instructed to graph the line using a dashed line, and what would the inequality have been if the solution included a solid line? I'll just summarize this by saying if your inequality is this or this, use a dashed line. If the inequality is this or this, you use a solid line. Because that line, everybody, I'm going to go back to this. Because that line is this. That's what the line is. So if equals to is included as part of the inequality, then the line is part of the solution, which means you draw it as a solid line. If there's no equal to as part of the inequality, then the line we drew, which is the equation with the equal sign, is not part of the solution. All right. So a summary here, and this is on the top of, I believe, the next page. I want to walk you through this carefully. The solution to a linear inequality in two variables is represented by a shaded region on one side of the equation line, either above or below. If the inequality contains an or equal to, then points on the line are part of the solution. If the inequality does not, then points on the line are not part of the solution. If the line is part of the solution, it's solid. That's how you shade a line. It's a solid line. Now, how do we determine which side of the line to shade? Because that bit of business, it's still on the right screen there. We're not going to do that every time. We're not going to find out if ordered pairs en masse are part of the solution or not. So we're going to be using what's called a test point, and then I will show you a different way to approach it. So the first thing to note is if I want to sketch this inequality, I have to rearrange it for y, because I have to know what the equation of the line would look like. So this would be 2y is less than or equal to negative 3x plus 12. I'm just subtracting 3x from both sides. So y is less than or equal to negative 3 halves x plus 6. I'm dividing everything by 2. So I graph now y equals negative 3 halves x plus 6. That is not the question, but it's what I graph. Am I going to be graphing this with a solid line or a dotted line? What do you think, Ali? Solid, because it contains the or equal to, which means that numbers that make this left and right sides equal are a solution. Those numbers are represented by points on the line, so they're included. The y-intercept here is 6, so it's going to go through 6 on the y-axis. The slope is negative 3 halves, which means you go over 2 and down 3, over 2 and down 3, and continue in that fashion. These steps I've drawn are just me explaining how you're going to draw the line. roughly like that. I really should be putting arrowheads on the end of the line, but you know that the line goes on forever. Now, it's a solid line because any point on the line is a solution. All we have to do, listen very carefully, this is going to make your life so much easier. All we have to do to determine whether it's below or above is pick any point anywhere, not on the line, and find out if it is a solution. So listen carefully. If I pick a point below the line and discover that it is a solution, then I know I'm going to shade below the line. And I can choose any point I want as long as it's not on the line. So what better point to choose than 0, 0? How easy is that to throw into the equation? If I put 0, 0 in, I will have, I'm embarrassed actually writing this out, I will have 0 is less than or equal to 12. True or false? Well, it's true. It makes the inequality true. That means that we can shade below the line. Now, is there another way we could have said we're going to shade below? And this is going to be... There's a weird twist to this, so be careful how you interpret it. Since this says y is less than or equal to, y is less than means y is below. Y is below means you shade below. Y is measured vertically. Somebody tell me why. How come? This has y is greater than, but it's shaded below. Do you know, Will? It's negative y. If I rearrange this for y, I move the y over here, and when I read it in the direction from right to left, it says y is less than, so I shade below. You can either pick a test point, or you can just look at the equation. And if rearranged for y, it's y is greater than, shade above, y is less than, shade below. All right, let's try another one. 5x minus 2y is less than. I'm just curious here, can you take a look at the structure of that inequality and tell me if we're going to be shading above or below? Above, right? Because the 2y will move over and become positive, and when we read it backwards from where the y is, it's going to be y is greater than. But we'll deal with that in a bit. When I rearrange this, it's 2y. Well, let me back up. What we are doing is imagining this equation so that we know what to draw for the line. This becomes 5x minus 14 equals 2y, which means y is equal to 5/2 x minus 7. It's not equal. It's an inequality, but I'm doing this to decide what to draw. The slope is 5 over 2. The y-intercept is negative 7. Negative 7 is where it crosses the y-axis. If the slope is 5/2, it goes over 2 and up 5. Over 2 and up 5. Over 2 and up 5. If you do rearrange it as an inequality, it would be y is greater than 5/2 x minus 7. So I just straw poll here. How many of you would decide which part to shade by looking at that? Okay, so y is greater than shade above. Otherwise, pick the origin. Unless the line goes through the origin, then you have to do something else. and put 0 in for x and 0 in for y, and you'll get 0 is less than 14. That's true. That point is above, so you're going to shade above. That's all there is to it. That's it. And you'll discover that when we look at this tomorrow with quadratic inequalities with two variables, it's the same thing. You're either going to shade above the parabola or below the parabola. I think you get the idea, but let's burn through this third one. If you think we're going to be shading above, put your thumb up. If you think we're going to be shading below, put your thumb down. So it's interesting that many of you have your thumbs down here. Is that because you're reading the inequality backwards? Because we're not going to move the y to the other side here because it's positive already. When we rearrange this, in fact, I'm not even going to write the equal sign. I'll have 3y is greater than or equal to negative 4x plus 12. I divide everything by 3. And I have y is greater than or equal to. But I have y is greater than, which means it shades above. I imagine this whole thing as being equal so I can sketch it. The y-intercept is 4. The slope is negative 4/3, which means you go 3 to the right and 4 down, 3 to the right and 4 down. We're going to sketch a solid line because equals to is part of the inequality. If you choose a test point, you put 0 in for x, 0 in for y, and we get 0 is greater than or equal to 12. Not in this universe. 0 is not greater than or equal to 12, so it's not a solution, which means that point which is below the line is not a solution, which means none of the points below the line are solutions, which means we shade above. So anything on the line in this one or above the line is a solution. Any questions with A, B, or C from that set of examples? Look, the last example, I don't care what you really draw here. It's just showing you how you could use your calculator. The only thing is, your calculator cannot show the difference between this and that. Okay? It's going to shade it, but it'll look the same no matter what. But it's a nice way to visualize it. So how do we do this on the calculator? We rearrange this for for y. So I move the 4y to the right side. I end up with y on the right side times 4 is 3x minus 12. Divide everything by 4, I get 3x minus 12. Are you in agreement there? Okay. So let's graph y equals 3/4 x minus 3, which is what happens when I divide everything by 4. 3x over 4 is 3/4 x. 12 over 4 is 3. Okay. If you were to go zoom 6 here, what's a line? That's no good. We don't want a line. We want a solution region. So go back to your y equals and scroll to the left of your y. And you'll see that your little cursor is blinking away there and it's showing a line. If I hit enter, the line is thick. Draw a thick line. If I go back there and hit enter again, it has this triangle. Let me see if I can capture that. Yeah. Now, what that triangle is a shading. This is your screen, and this is a line. So that is showing shading above the line. Which one do I want here? Do I want to shade above or below? Below, right? Because I read it in terms of y. This means y is less than 3/4 x minus 3. So I want to shade below. If I were to hit graph right now, it's going to shade above. That's not what I want. I want to shade below. So I go back to y. Basically, you keep hitting enter over here until you get the shading below, and we have it. I don't know what you want to draw here. It isn't really about what you're going to draw. It's about that you can do it on your calculator. The only thing is, should this line be solid or dotted? Dotted. And there's no way to tell it to do dotted and shade at the same time. By the way, there are other things it can do. I think the next one is the bouncy ball, which is useful sometimes. It's just going to show you the path that the thing is following. All right. I don't know. Do we need to do B and C? You rearrange the equation for y. You do it on your calculator if you're going to by going over to the left of y, hitting equals until you get shading above or shading below, whichever one you want. The reason why I'm not in a big twist about doing them is we only have about 15 minutes left, and I would rather you have some time practicing this on your own. Okay. So on page 472, questions 1 through 5. I don't know why I say all there. You know the drill. I expect you to do practice. Get to work, and I'll come around and give you a hand.